Hey guys, today we're going to do section 1.5, combination of functions. We're going to start this section together right now. So, given two separate functions, f of x and g of x, combination of functions, we are going to do operations with these functions, f of x and g of x. So, if you are asked what is f of x plus g of x, not even dealing with any input variables, we're just saying what's the sum of these two functions. What you are allowed to do is take each of the functions and add them together. So f of x plus g of x, input f of x and g of x, and combine like terms. The parentheses are just there to show you that the first one's f of x and the second one is g of x. So combining like terms, we can take the parentheses away. Combining like terms, we would get x squared plus 2x minus 3. So that one was not too complicated. The next one, f of x minus g of x. How does that change from number 1 to number 2? So looking here, we use parentheses, 2x minus 3 and the x squared minus 1. And we're subtracting these two. So go ahead and simplify this into the new equation for f of x minus g of x. All right, so distributing -1 for each of these, we get negative x squared plus 1, and that 2x minus 3 stays the same. So negative x squared plus 2x minus 2 would be what f of x minus g of x is. All right, multiplication. F of x times g of x. So parentheses, let me change the color here. I see them right up here, so I'm just going to use them. So 2x minus 3 and x squared minus 1. Simplify as much as possible. So for this one, what do we need to do? If you thought FOIL, you are correct. We are multiplying these two out. So FOILing, 2x times x squared, 2x cubed, 2x times negative 1, negative 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 1 is a positive 3. In standard form, we go the highest exponent to the constant, so we just have to reorder these two. So 2x cubed minus x squared minus 2x plus 3. These are whole new equations when you combine two different functions together. Then the last one, division. We are going to put f of x in the numerator and g of x in the denominator. What kind of problem does it arise when we have something in a rational form here? If you thought about the domain restriction when you now have a variable in the denominator, you are correct. You are allowed to have this. This is all we need to do. We're not doing anything else to these. However, because we now have a variable in the denominator, we need to make sure we say x cannot equal any values that would make the bottom equal 0. So off to the side, set that x squared minus 1 equal to 0. This is a difference of squares, so you could do x plus 1 and x minus 1. So the values that make this denominator equal to 0 is x cannot equal negative 1 or 1. So when you get this combination of functions, whenever you have a function in the denominator with a variable, you need to state that and put a comma and then say x cannot equal whatever you found over in this work here. So x cannot equal positive 1 and negative 1. So that would be your final answer for the combination of functions for f and g. So this is just in words. Hit pause and write this down. This here is just telling you that you have to find where the restrictions are when the denominator equals 0. All right, these are the formal definitions. Notice I was using the ones on the right. Oop, not this. I was using the ones on the right, but you can see when it says f plus g of x, what that means is you are just adding the two functions of x, named f of x and g of x. So this is just a simplified form, but they mean the exact same thing. Here, when you see the division of f and g, it means the same thing as taking your function of f and putting it over the function of g, but you are adding in when g would equal 0 and saying that it cannot happen. So pause this and write these 4 formulas down here. All right, so now we're going to go a little bit further. Now we have two new functions, f of x and g of x. They asked to find f plus g of x, and then we're going to evaluate that new function for when x equals 2. So our equation that we just learned, f plus g of x, means the same thing as taking f of x and adding g of x to it. So up here, here's our f of x, and here's our g of x. So 2x plus 1, and we are adding x squared plus 2x minus 1, and we're adding them together. I could have used parentheses. In this case, since it's addition, I did not put parentheses. I just showed you in the two different colors. So simplifying this, combining like terms, x squared plus 4x, and the 1's cancel. So the function f plus g of x equals x squared plus 4x. Now they are asking us to evaluate that new function for the number 2. What do we do with that number 2? If you said plug in, you are correct. So f plus g of 2. I'm going to plug in 2 wherever I see x in my new equation. So squaring 4 times 2 is 8, so this should be 12. So f plus g of 2 equals 12. That also means if you wanted to, you could have plugged in 2 to f and 2 to g, got 2 answers, and then combine your 2 answers with addition, and you should get 12. So let's check. 2 times 2 is 4, plus 1 is 5, so f of 2 is 5, and g of 2 is 4 plus 4 minus 1, which is 7. 5 plus 7 is 12. So that's correct. So you could do either or. Since they told you to find that first and then evaluate for x equals 2, you have to do it the way that I have down the bottom here. All right, composition of functions. I found combination of functions to not be as difficult. Just have to be careful of using parentheses and distributing negatives and adding in that domain restriction for division of functions. Here, composition of functions. You are taking a function of a function. So the word of, composition of. So when they say f of g of x, notice g is taking the place of what your input variable is. So you are actually taking what g is and you are plugging in, replacing what f's x is with the whole entire function what g is. So f of g of x is x squared. I'm drawing my skeleton here. I'm higher function g of x and simplifying. So we need to FOIL. So this will come to be x squared plus 2x plus 1. If I said find g of f of x, you are taking f and you are plugging it in for the g function. So f is x squared, and you are replacing g's x with x squared. So this one would be something plus 1, x squared plus 1. So this function is x squared plus 1. Notice these are not the same. Pause and write that down and highlight this exclamation point. They are not the same. So composition of functions is not commutative. This is a formal definition. Notice I was using the notation on the right. This open circle means composition of function. So f of, the word o for of, f of g, you do f and then parentheses g of x. The big thing here to note, when you do composition, sometimes you have to check and make sure your domain is okay. And we're going to go through that in class next time. All right, so one more example here. We have these two functions, and we're going to find f of g of x and g of f of x. Let's do f of g of x together. So this, by the definition on the previous page, is f of g of x. We are going to replace g of x with what it is, so x squared plus 1. So we're finding f of x squared minus 1. F is 2 times x minus 3, so 2 times x minus 3, and I am inputting x squared minus 1. So this will be 2x squared minus 2 minus 3, so that will simplify to 2x squared minus 5 for f of g of x. Go ahead and take a minute and hit pause and find the bottom one, g of f of x. If you had any trouble, for g of f of x, you're doing g parentheses f of x. You are plugging in, always go from the inside out, so 2x minus 3. This one is a little bit more challenging because you are squaring the 2x minus 3, whichever one's favorite. We're going to FOIL. So 4x squared, inner and outer would be negative 6x, so that combines to negative 12x. Negative 3 squared is 9 minus 1. So the composition function g of f of x is 4x squared minus 12 plus 8. So that is g of f of x, so I should put g of f of x, and I am going to rewrite that because that looks like multiplication, so be careful. Open hollow circle is composition. A closed circle is multiplication. All right, guys, let me know if you have any questions on this section. We're going to do more with composition of functions next class, and we'll practice with the combination of functions. Have a great day.